This is the introduction to a series of examples of how we use reaction type to predict products and write balanced reactions. We'll not do anything on here, but this is the series of steps that you must follow in order to successfully write a reaction if not all of the products and reactants are given to you. Process goes like this. I'm going to read it off real fast. If you're watching this video, you'll just need to pause. There's not enough time to write this all down. While I'm speaking, write the names of the elements or compounds that are given. And I'm just going to cut in real quick right here. This is me. Hi, this is me later. This is Mr. Atkins. I realized afterwards that I had made an egregious error in these notes, and so I need to go in here and I need to fix one thing. We, of course, when writing chemical reactions, do not write names in the chemical reactions. We write formulas. So we would not write calcium chloride, we would write CaCl2. I didn't catch that until later, so I'm sort of rather than remaking this entire thing, I'm just kind of butting in here, making that correction. As soon as the video replays, the word formulas will disappear because that's kind of an ink screen thing here on the computer. But please make sure to write that down correctly. It is formulas, not names. And now, back to the rest of the video. Given correctly as reactants or products, note they will not necessarily always say the reactants first. Sometimes they'll say the product first. For example, something is formed. It might say sodium chloride is formed. Formed means that it's made, means it's a product. So read it carefully, make sure that you are putting things on the correct side of the arrow. Once you have written all of the names of the elements or compounds correctly, then you ask yourself if it's an element alone. Ask yourself, is it diatomic? Is it a Hofbrinkel? Is it hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, or chlorine? If so, you need to give it a little subscript 2. If it's a compound, follow the rules of writing formulas. Type 1 or 2, you're going to go ahead and use the charges. For type 3, you're going to use the name, the prefixes, and the subscripts. And for acids, we follow acid rules. Once you've written everything correctly, you got to determine which reaction type it is, if not told, and then rearrange the products and reactants that should happen for that type. Now that is, number 4 is the big hang-up. Number 4 is what we're learning how to do, and we're going to have to do that with practice. Part 5, write the predicted new formulas correctly. Do not balance during this step. If you do try to balance during this step, you'll get everything wrong. Once you've written all the formulas correctly, then you balance it. That is all. Not much to this video. Oh wait, yeah, there's one more thing we need to talk about. We need to talk about an element versus a compound. An element has only one type of atom in it. So if I were to come across H2O, that is not an element. I can't do subscripts here. Yeah, I can. H2O. There we go. That's not an element because it has more than one atom, more than one kind of atom in the form. It has hydrogen and it has oxygen. If, however, I had P4, what's that? Well, it doesn't matter what it is. It matters that it's not got more than one kind of element in it. It has 4 atoms in it, but they're all the same kind. So that would be phosphorus. That's an element. And another example would be O3. You say, well, why is that O3? Why isn't it O2? Oxygen's a Hofbrinkel. Well, sometimes it's O3. That's ozone. But if you were given O3, you would know, well, that is an element because there's only one kind of thing. Whereas if I were to give you calcium sulfate, well, now we have more than one kind of atom. We have calcium, we have sulfur, we have oxygen, all in the same atom. So you got to be able to quickly look at a name or a formula I guess those are all formulas. If we go with names, if you were to come across lithium, you would say, well, that is an element. That's an element because it's the name of an element. Whereas if I were given selenic acid, that's not an element. Acids, we know acids are compounds. They have hydrogen and a negative ion, so they can't be just one element. There are more than one thing in it. If there's only one kind of thing in it, it's an element. If there's more than one kind of thing of it, it's a compound. That's going to be really important as we go through some of these examples of how we write reactions and predict products.